So I thought we would take a look today at privacy assistance technologies. And there's been a lot of stuff done in this area. I'll cover examples of different kinds of things. I apologize in advance if I haven't included your particular work here. I realize there's a lot of stuff here, but I wanted to step back and sort of get a sense of what has been done and where we are, what's working, what's not. What do we need to do to actually bring some of these things into sort of commercial production? So you all know that users need help with privacy. They don't read privacy policies. This is old news now. The world is continuously changing with new laws evolving, new kinds of sensors that are taking more personal data from us, cameras everywhere. And people have to typically make, when you get a new device, probably hundreds of decisions. If you reload, apps and your web services, and every day you go to a new website, you have to make new decisions. So we're supposed to consent, but there's way too many decisions to make for this to be sort of a manageable thing. Same thing with developers, okay? They also face a sort of continually evolving legislation and regulatory landscape. And there are privacy, building your systems with good best privacy practices takes a certain expertise. And unfortunately, there are lots and lots of, we don't have enough of those people, and many small and medium-sized companies don't even have that expertise on staff. So everybody needs some help. So let's talk first about what we've seen for that help for users. So there's a variety of different things we've seen. Some of them are just transparency, try to make users more aware of what's going on. Others are reminders. There's been some advancements in sort of automatically doing things for you, automatically setting privacy settings, which is an interesting space because users are supposed to consent to everything. And if we do it automatically, it's certainly helpful. It diminishes all those decisions we have to make. But it's a little tricky there to deploy that. Personalized recommendations. There's been a lot of great work coming out of Carnegie Mellon in that space, something I'm excited about, but hasn't really seen commercial adoption yet. And then the last thing, of course, the topic of the day is, chatbots. How can they help? So let's just have a quick look here. So I think you're all familiar with Play Store, and the App Store started launching nutrition labels or Play Store labels. Apple started this in 2020. And the idea here is that, they show you for each apps what they collect, and they're supposed to tell you kind of the purpose of what they're using it for. And Apple has the same thing. So is this helpful? Is it working? So on the one hand, I'd probably say it's still a little early to really make any conclusions about that. But there was a recent study by Zhang and Lori Craner from CMU, where they interviewed 24 people to see what their experience was. And interestingly, they saw that on the one hand, users like this because it actually helps them decide. They look at it to compare across apps to make decisions about which one to install. So that's a good thing. They do have misunderstandings about what this means. They think that this describes all of the data an app collects, when it really, the only thing that I believe developers are legally responsible to tell you about is anything they use for advertising. So it doesn't have 100% of the story. And the other thing this doesn't help with is that users often don't make the connection that if they see something they don't like, they should go into a separate part of their device where they could turn off sharing. Google and Facebook both have these things called privacy checkups. You get reminders maybe twice a year from them to go and look at this, and they walk you through, a bunch of options you have for your privacy settings. So that's a nice thing to have, but it's my understanding that in neither case, the majority of people don't even know this exists. What about a privacy chatbot? So this idea was actually proposed back in 2016 and some more work in 2018 from folks at EPFL and University of Madison, Wisconsin. And I think this is a great idea, actually. Since nobody reads a privacy policy, it'd be really nice if I could just ask my privacy chatbot, does this app collect my location? Or what does it do with my location? And I could find out the one thing I want to see in a privacy policy without having to read, 27 pages of text. So I'll come back a little later to how this is working, and we'll explain that. So what about ChatGPT? Of course, we have to look at this. So I tried this a couple days ago, and I asked ChatGPT if I should share my location with TikTok. Now you can see this answer. It depends on your personal preference, if you feel comfortable, and be sure to read the app's privacy policy. So this is basically content-free, in my opinion. Nothing I didn't know, and telling me to do something I'm unlikely to do anyway. So I tried to be a bit more, I asked a second question, should I share contacts with shopping apps? So this isn't focused on a single app, but just sort of a category of apps. And I got a kind of equally uninformative answer telling me that I should consider the benefits and the risks. Well, I mean, who really understands the benefits and risks? So ChatGPT isn't there yet. I'm sure it'll get better, but not today. So let's think about, what about solutions for automation? So this is a study that was done by a fellow in my group, actually. It started out for doing something different. We wanted to deal with the problem of permission spam and annoyance that happens on the web. And the idea was to see, under what conditions could notifications sort of be silenced. But I'll tell you what happened and how this became sort of having a second effect, which is nice for privacy. So you all know what notifications look like. They did a large study and found that overall about 10% of notifications, all the prompts that you get, including for location, are actually granted. The vast majority of them are notifications. The light gray or other things like camera and location information. But the vast majority of stuff is unwanted. That means users either dismiss it, they block it, or they ignore it. And so they did some work to figure out, is there a way that we can kind of automatically silence this to reduce interruptions? So the idea is to reduce interruption, but in case there's a mistake, and actually we thought the user wanted to turn it off, but they actually do, they need to have an escape hatch. So I think that's an important concept with the idea of automating controls or making decisions on behalf of the user. So here what they did, the escape hatch, is that they added this little chip into the UI, this thing here that says notifications blocked. I don't know if you can see my mouse there. And if you click on that, the notifications blocked thing appears in the URL. And if you click on that, you're told notifications were blocked and you can go and undo it. So, the good news is that it turns out that a tiny fraction, I'm not going to give you exact numbers, but a tiny fraction of people actually want to unblock that. So this is based on sort of machine learning that looks at users, previous behaviors. It's got sort of very lightweight models that are on device. It also uses back-end telemetry about Chrome. We do understand, about poorly behaving websites. And so when these notifications come, it tries to predict if the user's unlikely to grant it, in which case it's silenced automatically, and you have that little chip if you want to go and undo it. So this whole game, though, has to be done without sort of really impacting the things you want to accept, the grant rate. This is just an example of how the dismiss rate has gone down. Now, why does this help privacy? There's a couple ways. This has also been applied to location prompts, so that's a clear privacy benefit when those are automatically turned down. Notifications can also be a privacy problem because a lot of them lead to phishing, right, and so on. So there are some sort of secondary side benefits to that. And now, of course, I mentioned, you can only get this service if you've opted in to safe browsing. So there is sort of an opt-in mechanism for that type of automation. Let's talk about a different kind of automation, cookies. I think you all know the problem here. There are a lot of different kinds of websites that, when they ask you to consent to something, in some cases, websites that don't do a good job, they just give you an accept button, and they don't really help you get towards clicking sort of essential only kind of cookies. Some of them, like the second one here, has some weird language, like reject non-essential. Okay, that's kind of a double negative, then most people will be confused by the linguistics. That's probably what you should pick, but really, I'm sure everyone will stop and look at that and not really be sure what it means. The bottom example, allow only essential cookies, is nice. That's doing what it's supposed to. But it says also in the allow thing, allow essential and optional. So the word essential appears twice. All of these things, you're familiar with this, they're called dark patterns intended to confuse users. So wouldn't it be nice if you could have something that would just automatically run on your behalf and get you into essential only mode all the time without you having to do it and figure out every website's sort of different pattern here. So there was some work done by Rishab Kandal at the University of Wisconsin-Madison again, and they built this thing called the cookie enforcer. It's pretty clever, actually. First, they have to go and scrape the websites and actually sort of automatically click through the various options and learn what the pattern is for each website, how you get to the essential only mode thing. And they did that, and then they built a machine learning model so that they could figure it out automatically for new websites. And they built a browser extension to actually sort of build it and implement it and test it with users. So I'll just show you quickly. I thought this was pretty clever. As I said, like when you go to a website up there, you might see this first black box up here. If you click on customize settings, you get the stuff below, and that looks like what you're all used to. So what they did is they were able to scrape all this information, and they built a training data set, input-output training data set, where it basically just sort of states button 0 does this and button 1 does that, and the stars are going sort of to the next level in the menu system. And if you go through this whole sequence of events, the output here, which is for this website, how you'd actually get to essential only mode, is first click button 0 and then click button 6. And they trained a T5 model, posing it as a sequence-to-sequence task. And this works pretty well, actually. I think they were able, if I remember correctly, sort of 94% of the time, they're able to correctly predict the recipe, that's what they call it, for directly getting to essential only mode. So this is an academic exercise. This hasn't been built out, but it's an interesting example of trying to automate privacy decisions for users. Now, let's talk about a lot of work coming out of Carnegie Mellon, which I think is really clever and insightful. It started back in 2016 with Norman Sadeh and his large collection of colleagues. They wanted to build this personalized privacy assistant, and they were focused on apps, okay, so smartphone apps. And they built something. The idea, really, the basic idea is very simple. Why not build something like the traditional, book or movie recommendation system? You look at what users did in the past, you look at lots of users, use a matrix factorization algorithm, predict what they'll do next when they install a new app, and help them to be consistent, right? If you generally deny location for shopping apps and you install a new one, to make sure you don't actually accidentally just hit, oh, fine, go ahead for the sake of getting through the requests, these kinds of things could help somebody be consistent. So this is a picture from one of their original papers where it's showing you how many people are looking at your stuff, and it's telling you, we recommend for these 11 apps, you sort of maybe change your settings or do something different. So a very, very nice idea. Then they went even further and said, well, why not do this for the world of IoT, which is far more difficult, right? Because there's a lot of cameras around you. You don't even know they're there. How are you going to be told what their privacy policies are? What about all the medical sensors in the world? So they had this idea of building a registry where when you deploy a service in a room, you register all the sensors you have and what they do, and any device a user has on them. So smartphone was the way to start. Could pick up those signals. You could be notified if you wanted to be notified. In an ideal world, a system like this would know your privacy preferences and would set things for you on your behalf. So they showed here, but this becomes immensely complicated, as you can imagine. So every user has different preferences. Of course, that's the advantage, right? That it really can be customized. But if there's lots of video streams around you and you want your face to be blurred and every camera that picks that up, and some people don't care about having their faces being blurred, and then there's questions of where do you put the denaturing capability, and so pretty hard to deploy this stuff. But at a high level, it's a nice idea for users. Now, so what about really? Is this really feasible? So first of all, there's a big complexity issue. There's also a really fundamental challenge as to who's actually going to deploy these things. All right, let's assume it's some third party that is not connected to all the apps and services you use. So the user has to give a lot of very private data to this service. If they're going to deploy any kind of ML model on your device, they have to give away their secret sauce. So clearly, we need some sort of cryptographic protocols to enable that. And that kind of arrangement is somewhat doable. But it's really about trusting that. And this service sits in between users and all the services they use on the web. So imagine EFF is doing this, and they tell you to turn location sharing off Facebook. I don't think Facebook would be very happy. It doesn't mean they shouldn't do it, but they just have to deal with that tension. And then there's the question of how to commercialize it. So this is a nice idea, but pretty hard to actually maybe deploy in the real world. I personally am a fan of secure multi-party computation, homomorphic encryption, all those kinds of tricks. I do believe that may actually really help make this stuff real. We can do cryptographic inference today. Matrix factorization can be done on garbled circuits and other structures. It's not always fast enough, but there's a lot of work going on. Things are getting faster. I think a bigger challenge is that we can't actually do, in terms of computing on encrypted data, we're not doing training, right? We're not doing machine learning training on encrypted data yet. And so that breakthroughs there would actually help make something like this real. So just a quick few observations before we start talking about developers. There's a lot of different ways, privacy assistance here, between the transparency and the fully personalized privacy assistant, or things that are just focused on, say, cookies. There's a lot of different bits and pieces. I would encourage more work of that. I think each of the even very focused examples usually provides some interesting learnings. Transparency is helpful. It's a good thing to do, but I think it doesn't really get people where they want to be. Automation also, I find that promising, but whenever we do that, you have to be super careful about consent, and users need an escape hatch. If even machine learning isn't perfect, right? Even if you make errors only 2% of the time, since you're making decisions on behalf of the users, they need a way to realize that somehow and undo it. And again, privacy assistance would be great, but that's not ready for prime time yet. Okay, let's talk about developers. There's a lot of tools popping up on the market. Many of these do just simple things. They tell you how to write cookie banners. They actually will tell you how to write, give you sort of automated templates for privacy policies. Some of them are getting more sophisticated, doing some network monitoring, seeing what kind of data leaks from devices when you run your app, and so on. Checks is a new product coming out of Google. I'm going to tell you more about that at the end. And App Census is a startup that a bunch of folks at Berkeley have launched. These two are much more sophisticated, and I'll come back to tell you about what they're doing after we talk about privacy policy analysis. So one of the ways to help developers is to get things in those tools that are called privacy nudges. Now, I think you're all probably quite aware of the idea. A nudge is really like a behavioral economics idea, whereas you want to try to incentivize people to do something which is sort of pushing them towards good citizen behavior. So good privacy practices. So the question is, what kind of nudges can we create, and will developers be responsible to them? So this is one very early nudge. It was actually deployed in the Google Developer Console. It shows a developer what the denial rates are for permissions. So here you can see that for this particular app, the camera was denied 32% of the time. But interestingly, up in the corner there, the blue line compares you to your peers. And if your denial rate is much higher than your peers, you could sort of see that without being told which peers you're being compared to, but it's usually similar apps. And that may be at least motivation for developers to say, well, at a minimum, they should try to explain why they're requesting certain permissions. And maybe if users realize that there's a good reason for it, they'd be more willing to accept it. So that was something that was deployed maybe about 4 or 5 years ago. Another thing, this was work done by a different fellow on my team. We asked the question, can we motivate a developer to not ask for permission if it's unnecessary? But what is the definition of unnecessary here, right? Usually the user, if you're a Sudoku game and you're asking for location, it's pretty clear to us as users that is not necessary. But of course, the developer will tell you they have to make money because the app is free, which is a legitimate concern. So how do we define unnecessary, and how do we even get them to think about this? What they did was really to, again, the same kind of thing about comparing you to your competition. So we looked at functionally similar apps, and then the idea was that if none of your peers, so not just all the apps in the category, but people that are functionally doing the same thing as you are, if others are not requesting it, so if lots of Sudoku games don't ask for your location and you are asking for it, we can tell the developer, your peers aren't asking for this, And so actually, that this also has been launched in the developer console, and it comes up and says, less than 3% are asking, I mean 97% of your peers are not doing this. And we tell them users prefer apps with fewer permissions. So we're trying to motivate them by competition. So just very quickly, this was everything else you'll see me talk about today is leveraging the sort of NLP technology or NLU technology. And this was done 4 years ago or so. So before all of the real excitement burst on the scene. So this is an older model, but the idea was to use the app description, the text, and use that to build embeddings for apps. And then we could decide if apps were similar by looking how close they were in embedding space. So this works actually pretty nice. Developers are responsive when they see that. They often do a lot more than we expected, actually, because they're not obligated when they get this warning. It's a soft nudge. But a lot of them actually do retract a permission they had originally planned to ask for. Over time, this has affected billions of installs. And interestingly, what's been interesting to see is that the withdrawals or the removals of permission has happened across all app categories and all app popularity levels. So it wasn't just like some niche portion of the Play Store that was paying attention to this. However, the drawback of this thing is that we're really poking outliers, all right? And if you behave just like everybody else, you don't actually get a warning. So this is only reaching a smaller, still a lot of installs, but the Play Store is a huge place. So there's a lot of developers that aren't getting any nudges at all. So what else can we do? So before, many of you may work in this space, but before even ChatGPT hit the scene about a month ago or so, there have been amazing, exciting developments in the NLP world, even 3-4 years back, when BERT first came out and all those kinds of models and the ones that evolved afterwards. A lot of powerful tools. So let me just talk briefly a little bit about I'll tell you this is the last time I'll talk about work that's happening on my team. I'll come back to everybody else's work. So already there have been other works that showed. So the idea here is to leverage the reviews that people write in the Play Store and to run some pretty sophisticated analysis on that. And there was an initial work published in 2019 showing that if you actually can pull out some of the things people care about on the privacy front and show it to developers, they are actually responsive and they'll fix things. So that was a small study. They didn't, the technology didn't really pull out a lot of the privacy reviews, but the ones they did show that actually the developers responded. So that was very motivating. I already told you about the second study that developers are responding to the nudge that's actually been built in the developer console. And then there are other studies that show that negative privacy reviews correspond to low ratings, and developers do care about their ratings. So there's a lot of motivation to try to look at reviews and see what you can do. So we built this system called HARK. It takes all the reviews. There are millions and millions of reviews submitted on the Play Store. People write about anything and everything, lots of topics. They might even write about battery draining and system crashing and things having nothing to do with privacy. But they do also write about privacy. And so our idea was, well, if we can throw a lot of sophisticated analysis out there, what we could pull out would be themes. What are the biggest issues users care about? And quantify them. So these numbers are somewhat artificial here, but the point is to show you that if you can prioritize and talk about how big the volume that someone cares about, it can actually be motivating. And I want to point out here that what's really happening here is a different mechanism for understanding how users and their privacy concerns. So traditionally, the UXR world does surveys. A good survey might have 5,000, 7,000 people, or user studies that are very small, maybe 30 people, because you have to interview people. This is a different animal, right? Here, there's really no limit. We can look at millions and millions of pieces of feedback, so we can get some nice big numbers. I do want to say that each of these three methods for understanding users, they all have their pros and cons. So I don't want to diminish any particular methodology here. User studies, you get to talk to people and ask them follow-on questions, right? And with surveys, they're very structured. You can focus them in a direction and you can repeat exactly the same experiment over and over again. With this kind of thing, we get volume, which is great. We can learn new things as they arise. We can learn about things that, we didn't think to ask about in a survey. But there may be nothing in there. The text is really hard. It's very messy. I mean, people write with terrible grammar and a lot of slang, and so there's lots of challenges there. But the big numbers do motivate people, and so that is a nice thing to come out of this. Now, we also further break these things down into finer grain buckets. Like here, you can see it's split between location access and contacts, because really what we ultimately want to do with this stuff is convert it into something that's actionable. Tell a developer, well, what do I do with this feedback? Okay. And so here, at least we're focusing him in on it's a problem about location or it's a problem about context. We also have built an emotions classifier. We can attach emotions like anger, fear, and confusion to each review. And if you have a lot of reviews on a topic with a lot of anger, if I were a developer, I would make that your first priority, because it only takes one person to launch a lawsuit. So this is the kind of output we wanted to have. So let me just show you very quickly. It requires building a privacy classifier. You take a large corpus, you have to extract, is this talking about a privacy topic or not? And I'll tell you more about this one in detail, but that's hard, because I'm sure if I asked a dozen of you what the definition of privacy was, you probably wouldn't all exactly agree. It's a bit of an ambiguous thing. Next, we attach fine-grained issues, again, so we can understand very specifically the issues, but they're grouped into larger themes, creating a two-level hierarchy. This is to make it easy to glance through. No developer is going to go read 200,000 reviews, but they want to know a summary. We create automatic summaries for the themes, attach the emotions. There's other stuff in there. You can go read the paper. We rank the reviews. So if you want to just read a few to see what the theme is really about, you can do that. And then once we have all these tags and labels on reviews, you can do a lot of sort of trend analysis. Any of these things could hypothetically go, into a developer report. So let's talk just a little bit about how this is done. So you've got all these reviews, and the first thing you want to do is extract those that are about privacy. The next thing you want to do is attach these fine-grained tags. Something's about contact access, something's about, hiding files. The little green things go together in a bigger level theme. The themes get a title. The themes get summarized, okay? That's a well-known capability nowadays. You can easily pass it thousands of reviews, and it can give you a one-sentence or one-paragraph summary. Really, really helpful for digesting all of this stuff quickly. So I'm going to just tell you sort of in more detail about how one of these pieces works, because I think this is all the methodology here I'm going to show is really very much connected to what Richard was talking about yesterday in ChatGPT, that, as it is, it has limitations, things need to be fine-tuned for your use case. Some use cases are trickier than they might appear initially, and really the whole game now in this world is all about coming up with a good training set, right? The rest is easy. The models can be trained. But training it is the hard part. All right, so we want to extract privacy stuff. Now, if you look at the reviews in the Play Store, the earlier work said that there was less than 1% of the reviews are about privacy. Okay, so that number was off, but it was good early estimates, probably closer to around 3 or 4%. Nevertheless, you are searching for training examples, which are a needle in a haystack. And if you just do random sampling of reviews, you're not going to get a good training set. So what previous people have done is to look at keywords and regular expressions, and I would really discourage you from doing this. You will miss so much stuff. But it was good as a first try. We decided instead that we were going to use a trick from natural language inference, all right, which will help us retrieve examples of everything we think might be in there, any kind of privacy topic. So let me just, and doing that will allow us to generalize. So let me show you a little bit, just for those of you who may not know what this is, a quick example. In this game, you define a hypothesis. The city is humid right now, or the city is really cold right now. And then you look at a premise and you see what natural language inference can do is to tell you, does the premise entail the hypothesis? Okay, and it can tell you, in the case of the second example here, if I were to say Houston's freezing and dry right now, yes, that implies, intuitively, you can think of it as the premise implying the hypothesis. It implies that Houston is cold. So you would get, that's called an entailment. So how can we use this? A good idea for building these training sets is to take a set of, in this case, privacy taxonomies. you can use an ensemble of many privacy taxonomies if you want. So one of them was, we looked at Solov's that talks about violations. We used another one, Wang and Kosaba, that talked about privacy technologies. And for each concept in there, you come up with a hypothesis. So, for example, personal data disclosure is discussed. And what do we do with that? So the idea is to take all the reviews. The reviews become the premises here. And we see, do each of these reviews entail the hypothesis personal data disclosure is discussed? Now, if the entailment probability comes out high, okay, so the first one is talking about sharing your information. The second one actually says personal data. The third one says nothing about this topic, and it has a really low entailment probability. But I think you can see where I'm going. These entailment probabilities are going to I'll run every review against the hypothesis, and it's going to automatically pick out ones that are highly likely to be privacy because the entailment score is high. So we're getting to a maybe privacy label, and at that point, you can feed those to humans to do labeling. All right, so I won't go through this, but you see the idea. You come up with a taxonomy, hypotheses. You use NLI to grab that stuff, even if it's a small percentage of your data set. And then you can balance your sampling, right? And what you pass to the human annotator are things that are highly likely to be the stuff you want, but you do actually get the confirmation. And you can end up with a balanced data set, even though I started out with a very imbalanced one. I think this kind of methodology is applicable to a lot of domains. What we do with that afterwards, we, in this case, trained a T5 11 billion parameter model, and it works really quite well. So I just want to say that we pretty much use this kind of approach for everything in there. T5 is a multitask thing, so you can train all these things simultaneously, which also may be some helpful cross-learning going on. But the issue generator, the emotions classifier, everything was done with this kind of a model. So if you want to see more about this and the numbers on how it performs, I'd suggest you go have a look at the paper. How can all this stuff help developers? So here, for example, we ran our analysis tools on a set of the Play Store reviews. And this is just sort of a visualization. It's an example of a visualization. This is not a tool that exists anywhere. But, it's a way for someone to easily glance through the ensemble of what's going on. And so you can see, like, the biggest issue that people have is unneeded access. But you can see some interesting things, like over here in privacy controls, the biggest emotion is joy. Turns out people like privacy controls, actually, and they thank the developers for putting them in there sometimes. So you do actually see privacy positive reviews, which may come as a surprise to some of you. There's so much that's possible once you have all this stuff. You can look at time plots of themes, and this is, of course, interesting to developers when they see a spike. First of all, obviously, you can rank issues, but when you see a spike and something happened, you can ask yourself, well, what happened in January of 2020 to make that blue line go up? And that might help them figure out what it was that upset people. So what's still hard to do in this space is taking all this analysis. We can give them numbers to scare people. We can give you emotions to scare them into action. But sometimes developers, and we've talked to a few of them about this, will say, well, what do I do? Okay, I get it. It's important. What am I supposed to fix? And honestly, I laugh when they ask me this. It's like, it's your product, not my product. Don't ask me what to do. So I think they need help. They need more specific suggestions of directions of what to do. So just some things that are right now, a sort of a rule of thumb, or someone with experience can be thoughtful about this. If you have an issue where the dominant emotion is confusion, the problem is probably that your UX journey isn't great, right? Or the controls are too deeply buried in a system and somebody can't find it. Or maybe you just need to explain somewhere in the product what it is you're doing and why. Right? Things that have high anger or high volume, I would say take them seriously and prioritize that. If you get something that has a lot of joy, then just, give yourself a thumbs up and enjoy your success. Some feedback actually comes in with very specific requests. They want to, add some sort of privacy, controls, or add password, for example, requirements, access for documents or something like that. So that's obviously very easy. You know what to do. You consider the feature or not. But there's a lot more that could be done in this space of actually sort of taking the next step from all that analysis into more specific actionable insights. Okay, and then the last thing I wanted to talk about is privacy policy analysis. This is also an area that in the last 4 years has gotten a lot of attention, and I think is very exciting. So imagine if you can sort of automatically analyze privacy policies, the kinds of questions developers could ask themselves. They could say, does my app behavior actually match what I'm doing, what I say in the privacy policy? Because if there's a discrepancy, that's a problem. You want to know about that. If I update my code, do I need to update my policy? Usually the person who's adding some feature in a code, the software engineer, doesn't remember the details that are in the privacy policy. And so this can happen because of a disconnect of different people in an organization producing a product. And finally, does my privacy policy have contradictions in it? Update it. It's written by different people, or you're trying to be ambiguous on purpose. Those kind of things can pop up. So there's a lot of stuff that's possible here. So to get this stuff off the ground, again, this is a lot of work coming out of Carnegie Mellon, and hats off to them for doing this. They have been providing a lot of annotated data sets over time. The first one was on web policies. They actually got law students to do the annotation. So that was wonderful. In 2019, they released a set of Android app policies labeled. They've got one which is focused on opt-out choices. And privacy Q&A are privacy question and answer pairs, things that people might want to ask and what should be answered. Again, not all of these, but I think at least 2 of them were labeled by lawyers. So this has been really helpful to pushing research in this space. I'll give you just one example of how this has been used. There was some work, again, by the folks at University of Wisconsin-Madison. You can see there are really pockets of people here who have been working on these topics over time. But this was done in collaboration with EPFL in Switzerland. And the idea simply was to sort of take these long policies, break them into segments, and then they developed privacy policy embeddings. So custom embeddings here turn out to be very helpful, and that's, I think, pretty intuitive. All these language models that are trained on Wikipedia probably not going to do a good job on privacy policies because that's very legalese language. It's really a very different kind of beast. And so developing privacy policy embeddings really helped a lot. The earlier work wasn't doing this, and some of the very first work was just using SVM for the classifiers. Pretty simple stuff, but they showed it was feasible. And with the privacy policy embeddings, they built for the first really deep learning models using CNN architecture, and they built these multi-label classifiers. So just to show you a bit what that looks like, here's a segment extracted from a privacy policy. First thing you do is that they got the word collect in there. So you assign, the category gets the assigned data collection. The data type is assigned location. You can see geolocation there in the segment. And finally, the purpose is assigned personalization. So each segment can get multiple categories and so on. So Polysys was able to do really a very good job with 87% precision originally. As I said, this was the first deep learning model. And they showed you could actually generalize the learning. Of course, once the cat's out of the bag, other people jumped on this. So, for example, there's some work coming out of Europe, published in 2020, where they used, the next greatest powerful model. They used BERT, and they showed they could improve the performance another 5% or so, I think, on the F1 score. So this is moving forward nicely. What I love about this thing is that now this isn't happening anywhere, but you could imagine Consumer Reports, sort of running this policy analysis against lots of different privacy policies. And if you wanted to buy a fitness application, you could compare the privacy policies super easily across the 3 of them. So this doesn't exist anywhere. The people who did the Polysys work, they just showed that this would be feasible. But I would love it if somebody went to Consumer Reports and told them to try to do stuff like that. It would make it so much easier for users who don't read privacy policies, but could do a quick, obviously, comparison. So the big use of all this privacy policy analysis is really to help you, one of the most important uses is to help you figure out, is my code doing what my policy says? Okay. So there have been a handful of studies. I'm just going to sort of tell you some of the things they report, and I want to claim here that I'm just reporting what's in the papers. None of this has been sort of independently verified by Google. But there was some work by Ben Endow and others in North Carolina who analyzed, they had an interesting thing they added into their analysis, which was the ability to identify contradictions in different sentences in the policy. So they had to define an ontology and a lot of logic rules there, but they showed it was feasible. And actually, in the 14,000 apps they analyzed, they found that 8% of them had contradictory policies. So even if that doesn't happen very often, if a developer has that, they want to know because they're probably in legal, not a good legal place. If that. Some more work by Sebastian Zimick and others at Carnegie Mellon here. They analyzed 1 million apps. They have a slightly different model, but they found there that a little less than 3 apps, apps on average had almost 3 sort of potential compliance issues. I think they were refraining from definitively stating they were compliance issues. They called them potential compliance issues. But I think the point is here is that it shows that apps do have problems, okay, with code matching policy or policy being self-contradictory. And so they very much need help. Now, you'll forgive me if I take 2 minutes here to share with you about a new exciting product coming out of Google. There is a product called Checks. It's already in beta. It is exactly intended to help developers in these sorts of ways. So it is powered by state-of-the-art natural language understanding techniques. I will say that academia, all the work that you guys have done has been helpful and was motivating. So you do have indirect impact on industry. So this is a really powerful tool that's taken these various ideas and built, even more powerful privacy policy analysis methods. And what this does is, you just see here, and this is a mock example that they use in their demo. It says here, it looks like you collect or send installed apps, but you don't disclose this in your privacy policy. So developers can get this feedback before things ever get deployed. And they run lots of checks, okay? If you get a red signal, it means you better really pay attention. This is a bad problem. Purple ones are potential issues. Maybe you need to look a little more in. And the green ones are all the checks that you've passed. So this is, again, based on the sort of basic infrastructure I alluded to earlier. You look at 3 things. What's an app supposed to do? What's it required to do? So the good thing about this kind of tool is that it's up to date on all the legal requirements, right? They have lawyers. They know what is required, and for all the jurisdictions around the world. They look at what your privacy policy says, and they look at what your code does, and they can give you a lot of feedback by triangulating around these things. So let me just end by sort of looking back and saying here that I think privacy assistance for users, a lot of the research has been focused on particular use cases like managing cookies. I think that's really useful work to do. I think we learn a lot with each sort of case we study. I think personalized privacy assistance may really be a helpful recourse for this problem that we have where we just have to make so many decisions. Okay, and it's too much. And it would be much simpler if I could just sort of state what my, say, privacy persona was. I will share location but not contacts, or vice versa, or I'll share location with certain types of apps or websites, and then have the decisions be made on my behalf. But as I said, there's too many issues in how that gets deployed, where users' data goes, how companies can commercialize it. So there's a lot of work that still needs to be done there. Machine learning as a service, some of you probably work in that area. Again, very promising, but I haven't really seen a lot of work there that's focused on NLP use cases. So I would encourage that. We still need more work on really, when you analyze feedback from reviewers, whether it's reviews or other kinds of text corpuses, we're still, we could still do a better job at actually really helping developers figure out what do I actually fix, And then, of course, I'm sure you're all thinking about this already. All of these systems require that you prevent against data poisoning for all the machine learning models that you're learning. So let me stop there, and I will take some questions.
Hey, this is not something I thought I would be saying. Chat GPT.
That's right. I think, so I'm from Indiana University, and we do a lot of work in this space. But we do it from the basis that users should be able to understand the risk and benefits. And right now, users only get the benefits. And when we have presented simple risk communication, individuals change the apps they install. And if you look at it from an economics perspective, developers are people too, and they're all very nice. But if you say what we need to do is change how people are interrupted by security, is change what apps are selected by empowering people to make their own decisions and giving them the information at point of purchase. So I want to encourage you to think about this as a risk communication problem. Look at some risk communication work on this, and not to treat people as data generating objects, because you can do that in everything but risk. Like this morning, everybody wanted to go to the gym, eat right, exercise, and be healthy, because we all want to be healthy. But instead, most of us had a piece of cake, right? So if we build like as if people are not active participants who have goals that they want to reach in addition to just being data objects, we're going to have a very different approach. And I want to encourage you to think about maybe we should be talking about risk communication.
I completely agree with you, so I don't really have a lot to add. I do think we need to figure out risk metrics and communicate those to users. Risk metrics are hard to do. I guess they're changing all the time, but I absolutely think that's a great idea. And those could potentially be shared through these kinds of privacy assistance that we're talking about, or other mechanisms with safety labels maybe. But yeah, I agree with you.
That was a great talk. I was wondering whether you consider, but I'm Kang from University of Michigan. I worked on policies and many other stuff, by the way. You didn't mention about the tool to help regulators. You talked about developers and users. Did you give some thought on how to help regulators to check whether all these privacy policies and laws are followed or not?
So let me say a couple things. I think by sharing this information with developers and helping them to avoid getting in trouble before they actually launch and deploy an app, that will hopefully diminish engagements or things that they have with the regulators. I agree with you that a lot of the privacy policy analysis, if you look and compare them all together, you can learn interesting things about what people are doing, and maybe whatever kind of tools might be made available to consumer reports, those kind of things could be made available to regulators for them to get a summary, of where things are and what apps are doing. But the personal behavior that I was talking about, whether your app is doing what your policy says, this is usually done pre-launch, right? People upload their tools, they run these analysis before anything's launched. So hopefully they have a chance to fix things beforehand. Yes, I didn't talk too much about regulators and developers, but there's no reason, I think especially for all the privacy policy analysis stuff, that we wouldn't have tools to help them look quickly and sort of see what's going on.
Very interesting. Very interesting talk. Thank you very much. I was wondering, so the ChatGPT answer that you got was very characteristically both insightful and banal. But the one thing that it mentioned is that you have to, told you that you should really understand your risks and benefits of sharing information. And it feels to me like the things like nutrition labels and privacy systems and so forth, they make more transparent what information is shared. They explain why, sort of try to explain the benefits of it. But do you know of any work that really tries to better educate users on what the risks of sharing information is? In the sense that, if I say, okay, I'm being tracked, what does that really mean for me? My location is being used by Google Maps. What is that, how do I translate this into something that matters to me today?
So unfortunately, I'm not aware of a lot of stuff that's helpful for users. If you go to the Play Store and you look for privacy assistance apps, what you'll typically find there are things that they call themselves privacy assistant. They're really security. They're malware, phishing, things that help you find that and be aware of it. There are some apps that will try to let you know if you're subject, if you are at risk for identity theft. So I don't know how they work or where they get the information from. So that is out there. But I think the general case that you're talking about, broad data collection and tracking, I'm really not aware that that's what the point that the woman here from Indiana was mentioning as well. We need a lot of work in risk. That's a hard area, but a lot of stuff we could do in that. If you're aware of some apps, please do let me know to do that. Here's my question for now.
Thank you for the great talk. I'm Tian from UCLA. I want to hear more about your vision for the future of privacy assistance if the crypto tools such as secure multi-party computation becomes more practical and more scalable for
Yeah, so I think assuming the crypto tools are in place, I think it would have to be run by a sort of independent party, who's not directly involved with other user apps or the developers themselves. So someone like the EFF or some other agency would be responsible. A really important part is trust. That's so hard these days, but I think an independent entity, third-party entity with all these crypto tools that can come to be would help a lot. I think another important thing in that space, I mentioned just briefly this concept of a privacy persona. Most individuals don't want to have to make 100 decisions, right, about everything. But it would be nice if I could sort of find a way to maybe answer 10 questions and tell you what are the things I care about. And based on that, you can create a persona for me, and then you just do everything that persona would want. I would guess, I don't know this, but I'm just guessing, there may be a dozen privacy personas out there. We're not all the same, but there aren't 100 of them, I suspect. So, if there's that another kind of research area that might sort of diminish the ability of machine learning to do that and allow users to state generally, what they do
Thank you, Nina, for the great talk. This is Wan Mumbai from the University of Queensland, Australia. So my question is regarding most of the time, as you mentioned, we rely on the functionality statement application to give us what kind of permission, what kind of data the application is really needing. So I'm thinking from another perspective, like data minimization. If we are able to clearly define or infer the functionality provided by the application, then we can kind of formalize this function when we need particular data. Is it going to be a better way compared with functionality similar application which can be subject to the pointing attack as you mentioned?
So I didn't hear everything you said, but I think you're asking about data minimization. So that's a best practice, obviously. GDPR and other places as well. There are a lot of machine learning tools out there right now which can help you assess how much data do you really need to build a machine learning model. And so to the extent that those can give a developer maybe insights that, the minimum amount you collect per user or the minimum types of data and so on, I think those could be helpful. The challenge with that is that in order to use those things, you actually need a lot of data to figure out what you actually don't need and what's excessive. So there needs to be a way to run that, in a one-time test environment where you're promised to delete things. And so exactly how to deploy those things, I think we still need to work that out. But there are tools to do that.